For what integer c will the right triangle whose legs have lengths root 3, root 4 have a hypotenuse whose length is root c? So let's make a right triangle and let's put that hypotenuse and then the other two legs, and let's see what we get. So according to the Pythagorean theorem, the famous Pythagorean theorem, it would be root 3 squared plus root 4 squared is equal to root c squared. Correct? So we have 3 plus 4 is equal to c, and therefore c is 7. For what integer n is the average of the first n consecutive positive integers equal to 10? So you guys remember that formula, right? If you have consecutive integers all the way to n, that can be added with the formula n times n plus 1 over 2. So what they're saying is something a little bit different. They're saying that you have numbers that are consecutive integers going up to n, so 1 plus 2 all the way till n. But then you're taking the average, though. So you take the average by dividing by the number of terms, and in this case, the number of terms is n. And they're saying that whole thing is equal to 10. So that's the math there. So this shouldn't be too difficult to figure out. The top is this guy. So it'll be n times n plus 1 over 2. And then I'm just going to cross multiply the n here with the 10. And then let's cross multiply again with the 2, so we get 20n. And then drop the n from both sides, and we get n plus 1 equals 20. And therefore n is 19. February 14th, Valentine's Day, falls on a Tuesday in 2006. What is the first year after 2006 in which Valentine's Day falls on a Tuesday? Okay, so 2006 we have February 14th. And that is, what are they saying? It's a Tuesday. Okay, so I've got to go all the way till when? Oh, they don't tell me. I have to figure out the year when February 14th again falls on a Tuesday. Okay, how do I do this one? All right, well, there's 365 days in a year, right? Except for leap years, and the leap years would be 366. Now, if you go from Tuesday to the next Tuesday, right? Like if today was Tuesday and I say, till next Tuesday, how many days is it? It's 7 days. And then if I said, what about the next Tuesday? Another 7 days, and so on. So if you're going from Tuesday to Tuesday and so on, it'll be a multiple of 7, either 7 days or 14 days and so on. So we got to first work with 365. Is that a multiple of 7? And I don't think it is. I think 364 is a multiple of 7. So every 364 days from this, we would get back to a Tuesday. You see what I'm saying? So when you get to 2007, I mean, from 2006 to 2007, there would be 364 days plus 1, right? Because it's 365 total. So because of that plus 1, that kicks us to the next day. The 364 would bring us to a Tuesday, but the 365th day would bring us to a Wednesday. See how I did that? Okay, now we get to 2008. 2008 was a leap year. I don't know why I wrote leap year. And that means there's 366. So, what does that mean? So, that means we had the 364, which is a multiple of 7, but then we have 2 more than a multiple of 7. So we have to jump 2 more days from the Wednesday. So that would be Friday. And then 2009, again, that would be 364 plus 1. So we got to jump ahead 1 day, so that's Saturday. 2010, jump ahead also 1 day to Sunday. And then 2011, again, jump 1 day over to Monday. And then 2012, that's a leap year, right? Because it's every 4 years. So that'd be 364 plus 2. And that would jump over to Wednesday. But here's the thing. This is actually a more difficult question than I initially thought. The leap year in 2012, so I got to write that actually. In 2012, the leap year happens at the end of February, right? Happens on, what is it, February 29th. So that extra day would happen after February 14th. So because of that, this is actually not a +2. It's actually just a +1 until we get to February 14th. And then after February 28th, we get an extra day for that year. So we really are just working with +1. So this will become a Tuesday. So finally, that February 14th would actually be a Tuesday in 2012. In a quadrilateral with an inscribed circle, segments connect each of the quadrilateral's vertices to the center of the circle as shown. What is the degree measure of angle X? Okay. All right. Oh boy. Well, let's see here. I'm going to have to divide these. And how do I do that? Let's see here. Well, I really don't want to draw these guys because it makes it so, how you say, messy. But I think I have to. I have to draw tangent lines. So there's 1, there's 2, and there's 3. Hold on. There's 3. And do I have to? Yeah, I got to draw 1 more. Sorry. Well, it's not too messy. I thought it would be really messy, but it's okay. So what's the point of drawing those tangent lines if you can even see them? They're so faint. It's to illustrate that, it creates those right angles like that. And you guys get the point. So when you create right angles, what you've done is you've created equal angles. So for example, this angle in here and this angle in here are equal. So I'll call those, for example, let's say call them A, that angle. And very similarly, this angle and this angle are equal. So we'll call those B's. And then let me use a different color because this is getting a bit confusing. This angle and this angle, we'll call it D. And this angle we'll call C. Okay? And that's from the properties of those triangles because you have the same, pretty much the same sides, right? Because you have the radius and then you have these points, like this and this are equal. That's a property that if you have tangent lines that originate from the same point, they will be equal in length. So those are essentially the exact same triangles that they create. That's why those angles are equal. Okay, so then now we can figure out, the only thing that we can figure out initially is that D plus C is 70. That's what they gave us. But we know one thing for sure, that if we took all the angles all the way around, so in this case it would be 2A plus 2B plus 2C plus 2D, that would be equal to 360. So that basically means 180 is equal to A plus B plus C plus D. But this is 70, so that's very helpful. So that's A plus B plus 70, and therefore A plus B is 110. And A plus B is X. If you can see, it's hard to see, but because I wrote all over it, but that was basically what X was. It was what I eventually called A plus B. So there you go. 110 is the answer. A theorem due to Fermat, but first proven by Euler, says that every prime which is 1 more than a multiple of 4 can be written as the sum of 2 squares in one and only one way. For the prime 818101, what are the 2 positive integers, which in this case differ by 19, whose squares satisfy this theorem of Fermat? Okay, there was a famous contest in Canada, I think it was grade 11, named after this mathematician. And I used to always pronounce it Fermat, but it's actually pronounced Fermat because I think it's French or something. Okay, anyhow, so let's first understand what they're talking about. So this thing right here. So if you have a number that's 1 more than a multiple of 4, so let's go with the first one, so 4 plus 1. That, they're saying, can be written as the sum of 2 squares. So I think this would be 1 squared plus 2 squared, right? So this is a perfect example of the theorem. Let's see if we can make one more example. How about 12? That's a multiple of 4. 1 more of that would be 13. And that I think would be, let's see, 2 squared plus 3 squared? Yeah. 4 plus 9. So this is another example. Okay, so basically, that would basically lead to the following, that 4n plus 1 is equal to a squared plus b squared. That's sort of the general kind of way of writing it. And then they give us this number, 818101. So I guess this is the 4n plus 1. And then they tell me, they give this is actually a very helpful clue, almost crucial, that the two numbers differ by 19. So that means that a is equal to, wait, hold on. Yeah, they differ by 19. So if a is greater than b, that means a minus b is equal to 19. So that means a is equal to 19 plus b. That's very, very helpful. So I can sub that in here, 19 plus b squared plus b squared. And I think that's it. I mean, what I mean is that's sufficient for us to figure this out. Yeah, we're going to eventually figure out what are a and b. Okay. Positive integers. Okay, here we go. So I guess I have to expand this. So just a bit of algebra here that we have to deal with. 19 squared plus 38b plus b squared plus b squared. Put everything on one side, and we get 2b squared plus 38b minus 817,740, and then divide through by 2. We have b squared plus 19b minus 408,870. And at this point, there's going to be some factoring. You can use a quadratic, but it's up to you, really. If you want, it's a long quadratic, but I can factor it. 630 and 649. So that means that b is equal to 630 because it has to be positive, so it can't be minus 649. Yeah. And then a, well, a is this guy. It's 19 plus b, so a would be 649, positive. So these are the values of the two integers that satisfy the question's conditions. What are both pairs of integers x, y for which 4 to the power of y minus 615 is equal to x squared? Okay. All right, well, we have this 4 to the power of y minus this 615, and this is equal to x squared. So I think I want to make a substitution. Let me just fiddle around with this first. This is 2 squared to the power of y, right? So it would be, if I interchange it, it will be 2 to the y squared. Yeah, so what I'm going to do is I'm going to let, this really isn't a let. That's sort of, it is what it is. But I'm going to let 2 to the power of y equal something. Let's call it a. And that way this 4 to the power of y is a squared. And I just think it makes it a little bit cleaner, a little bit easier to understand. You don't necessarily need to do that, but I think it's nicer. Okay, so now this thing becomes a squared minus 615 is equal to x squared. And then if I put just the a squared and the x squared together, it'll be like this. A squared minus x squared is equal to 615. Okay, so this is a fairly simple factoring job. Minus plus 615. Okay, now what? Now I guess by inspection I have to figure out what possibilities we have for these guys. Well, you can have 1 times 615. That's one way of doing it. 2, no, it doesn't factor into, it's an odd number, but 3, I think it does. 3 and 205. Or it could be 5 and 123. Or it could be 15 and 41. Right. So I guess I got some work here. So I've got to make a table and figure out which of these actually. Let me go back and read the question again. Just integers, that's all it says. So which of these create integers for a and x? Okay, so I have a minus x, a plus x, and then if you add these two, a minus x plus a plus x, you would actually get 2a, correct? And therefore a would be, you'd be able to figure that out fairly easily, just divide by 2, and then x you can just get fairly easily after that. So let's see here, the choices are 1 and 615, 3 and 205, 5 and 123, 15 and 41. All right, let's see what we get. So if we add them, we get 616, 208, 128, and 56. And then divide by 2, you get 308, 104, 64, and 28. And then x, you can easily get, for example, from this or this, right? You have the value for a, and a minus x is 1. So therefore, in this case, it would be 307. In this case, it would be 101. This would be 59 and 13. Okay, so what? Well, let's see here. Okay, so how do I choose which one of these? I think we have to go back to this point right here, this guy. If you remember, a is equal to 2 to the power of y. So a is basically a multiple of 2. Yeah, so the only one that's a multiple of 2 for a is this guy. That's the only one. So that means a is 64. So 64 is 2 to the power of y. So that means y is equal to 6. And then we have to figure out x, right? Yeah. X, where do we figure out x? Oh, we go back to the original equation. So 4 to the power of 6 minus 615 is x squared. So solving that, you'd get x is equal to plus or minus 59. So I guess the solution, we put it up here, x, y, two solutions. We have 59 and 6, and we have minus 59 and 6.